In this video, we're going to look at the levels of measurement for different variables and how we identify what level of measurement is appropriate for that particular variable. So we have 4 levels. The first type of variable we see is at the nominal level, and this is generally considered to be the lowest level. So in this case, we would have values that were only consisting of names, labels, or categories. So here, there's no order to these values. Sometimes people think about alphabetical order, but if we were listing the names of countries in the world, then we could list them alphabetically, but that doesn't make the order about the actual countries themselves. So that's just the names of the countries, and if you translate it to a different language, then they'd be in a different order. So it's not that particular data variable that would be in order. So nominal, there's no order to it. Names, labels, and categories. Ordinal, data is still categorical, but there is an order to the values. We just don't have differences between values being meaningful. So these are both categorical variables. And then we go on to interval and ratio. And these are both quantitative variables. So at the interval level, differences between values are meaningful, but there is no natural zero starting point. There's not too many things that fall at the interval level. So what you'll mainly see for this is temperature, because if we're talking about degrees Fahrenheit or degrees Celsius, 0 degrees doesn't mean that there is a complete lack of heat. It just happens to be where the scale is falling. So it, for Fahrenheit, it doesn't even mean that that's the freezing point of water. That's at 32 degrees. So temperature would be one example of something at the interval level. If you ever see temperature, you want to immediately identify that as interval. The other thing is years. When we're talking about time and we're naming the years, 1953, 2007, that kind of thing. That would be at the interval level because, again, there wasn't even a year 0. So we go back and we have ACE and BCE. And so, again, no natural 0 starting point. So both of those would be at the interval level. Other than that, you're really not going to see very much interval. So if you are guessing and you know that the data is quantitative, it's better to guess that it's ratio. It's much more likely to be ratio than interval. Just there's a lot more examples of ratio. At the ratio level, proportions are meaningful. There is a natural 0 starting point. So let's take a look at some examples and see how we can identify what the level is for each of these variables. So we're just going to go in order. The first one's going to be nominal. So in this case, we have a list of subjects. So we just identify them as subjects 1 through 10. And then each subject gave their favorite color. So blue, yellow, green, and so on. So we have these lists of color, or this list of colors. And notice that if I make a little chart, a little bar chart that represents this data, so I have blue, I have yellow, green, red, and purple. And then I can show the frequency for each of those. We had 3 individuals who chose blue, 1, 2, 3. So we can see that that's 3 here. So when we get into chapter 2, when we look at bar charts and histograms, this is the kind of thing we'll be doing. But notice that the values here on the horizontal axis, those are the different colors. I could have put yellow first. There's no reason why they're in that particular order, and there is not a way to say, oh, well, there's a certain separation between blue and green, and that's equal to the separation between green and purple. That doesn't have any meaning here because this is only categorical. So that's what makes this nominal. Usually pretty easy to identify nominal. Now let's take a look at ordinal, which is next. So here I have, again, my subjects 1 through 10, and then I have their t-shirt sizes. So we have a listing of those sizes, and again, very much like the nominal, where we have the individual values. And is the difference between small and large the same as the difference between medium and extra large? Not necessarily the case. So we have a certain order to these sizes. I wouldn't put large first and then medium and then extra large and then small. That wouldn't make any sense. There is an order to these values, but they are not numerical values. And be careful, sometimes you'll see in your data, they will assign numerical values just to show the order when that's not necessarily indicating that the difference between two values is meaningful. So if I said, I'm going to label these instead of small, medium, large, extra large, for whatever reason, I labeled them as 5, 10, 15, 20, it doesn't make any, it doesn't give any meaning to those particular numbers. Those are just labels. And it's just showing that 5 is the smallest and 20 is the largest, and 10 and 15 are in between. So order is important. So I say that's ordinal. Still categorical values, but there's an order to them, so that makes it ordinal. Next, we have interval. So I've depicted this a little bit different because now we've crossed over to quantitative values. So we have our subjects and we have what the high temperature was for, I don't know, some certain days or whatever the data is coming from. So we have different values, 76, 84, and so on. So numerical values, there's an order to them, but the differences are meaningful. So if I look at the difference between 76 and 84, I would say, well, that's an 8-degree difference. And 65 to 77, oh, well, that's a 12-degree difference, so that's not the same, but, you can talk about the differences between two values, and those values have meaning. So we can see these laid out in the chart, and that is certainly quantitative data, but again, if we went down to 0, that doesn't mean that means there is no heat whatsoever. So there's no natural 0. That makes this one interval. And what we see most commonly is the ratio level. So here we have a list of 10 subjects and then their heights in inches. And again, we're looking at the frequency distribution. Now, you don't usually see a table or either a table of values or a graph that shows the data. They'll just say, oh, it's a list of heights in inches. So this is just to help you kind of visualize, how do I know that differences are meaningful? Well, imagine a few values, it doesn't have to be a lot, and then look to see, are the differences meaningful? Yes, they are. Because if we have a 2-inch difference in height between two people, then that gives us a picture of what's going on in the variation in height. There is a natural 0 starting point, which means that if somebody was 0 inches tall, then they would have no height whatsoever. Now, obviously, somebody can't be 0 inches tall, but that's what 0 would represent. It would represent a total lack of height. So it doesn't mean that 0 has to be a potential data value for your data set. It just means that 0 would indicate a lack of that quality. So, so this would be ratio. And another way to determine that your data is at the ratio level rather than interval is to look to see, are proportions meaningful? Could one person be twice as tall as another? Or 1.5 times as tall. It's hard to be twice as, maybe an adult could be twice as tall as a child. That makes sense. So you have a child who's 36 inches and you have an adult who's 72 inches, and sure, so one person could be twice as tall as another. So proportions are meaningful. Whereas if we go back and look at interval, we can't say, oh, it was twice as hot on the day that it was 70 degrees versus a day that was 35 degrees. So that doesn't really have any meaning to say, oh, twice as hot. You can say how many more degrees it was on one day than another, but you can't represent that with a proportion. So I always think about proportions when I'm looking at quantitative values and think about, are the proportions meaningful? And if they are, then I say ratio for that. And if they aren't, then I would say interval. So that's a little summary of how you determine what the level of measurement is. And you can find more information in your textbook.